Okay, so we'll rename this to vector summation integral. Okay, so vector summation integral. I believe this is the topic this is the name of the topic that would better that would better represent what we are talking now. Vector summation and integral. How when we are trying to solve a problem by dividing into n different parts, because now if I start using vector in computation of the nth part, any part out of n part, if I have a problem in I have a big problem. I believe some session we took up for the n number of coins, n number of people, but we did not use vector. Vector comes into the picture when we have problem in more complexity. Okay, if problem is less complex, then numerical science is enough. If problem is less complex, then numerical science is enough. If problem is more complex, then algebra comes into the picture. And then if it is more complex, then to deal with the algebra, to do the computation over the algebra, then calculus comes into the picture. Okay, if everything grows to a certain limit, then vector comes into the picture, and vector is considered as the end in the sense, now we have an entity which tackles direction also, not only the magnitude, direction also. Like if I say that one person is walking, a person is walking on a ground, a person is walking on a ground. What is his velocity? Velocity is t. What is t? T means time. He starts at t equal to 0. Yes, he starts at t equal to 0. Now his velocity is t. When t is r, hour. Okay. When 1 hour is passed, at that moment his speed is 1 kilometer per hour. That is his walking speed or running speed whatsoever. When he is at one point, when someone is watching his watch, then he is at 1.5 kilometer per hour when the time is 1.5 hours. This is how his velocity is, his speed is. Okay, another person is walking on the same ground and his velocity is t squared. He's very smart guy. His velocity is t squared. Okay, at the end of 1 hour, his velocity is 1 kilometer per hour. At that moment, I would rather say. From 0 to 1 hour, his velocity is less than t. T square velocity is less than t. But beyond 1 hour, then it goes like exponential whatsoever. But this is how it is. Okay, now someone is scratching. Two guys are running or walking on the same ground, right? Yes, on the same ground. Okay, can I consider the begin point at same point? Yes, at time t equal to 0. Did they start at the same time? Yes, they started at the same time. Okay, did they start from the same position? Yes, they started from the same position. Okay, then one guy is moving at t kilometer per hour. T kilometer, where t is the time and another t is square. What is the direction? Okay, one is going, you have seen that building in the ground. That building you have seen, that green color building. Yeah, he is going towards one, and one you have seen a big tree is there. Yeah, what is this? So vector comes into the picture. Only quantity does not matter. Vector is required. I would say the velocity of the first guy is ti, I vector. I means eastward, j means northward, minus I is westward, and minus j is southward. So he is going ti. Okay, what about another guy? Another guy is going t square in the direction of I plus j by a square root of 2, means unit vector. I plus j by a square root of 2. Okay, he is going in northeast direction. Yes, he is going in exactly in northeast direction. Or he is going in 2I plus j divided by a square root of 5. Or he is going in I plus 2j square divided by square root of 5 into t square. Okay, so this is typically called full-fledged magnitude and direction. Okay, now if someone is watching this, this is more or less called algebraic vector. Algebraic vector in the sense if I say his direction is I plus j by square root of 2, then full vector is t square by a square root of 2I vector plus t square by square root of 2j vector. This is called algebraic vector. Means vector magnitude is changing. If magnitude is changing, direction is also changing. Right now, direction is not changing. T square by square root of 2I vector plus t square by square root of 2j vector. If I keep changing the t square, t, then direction will not change. Only magnitude is changing. Where direction will change? You tell me. Where direction would change? Okay, let's say let's say okay let's say it is kind of ti plus t square j. There is a third guy coming into the there is a third guy. He is coming into the picture, and third guy is very smart. Okay, what is his direction? His direction is I plus minus t by I plus minus t by a square root of a square minus t square j, something like that. It is more or less like a circle. Okay, it is moving in a circle. Anything, whatever you want, you can represent it through vector, magnitude and vector. If I say there is a guy who is ti plus t square j, if you keep changing t, the magnitude of his velocity would change. Magnitude of the velocity would change if you change the t. And also the direction. When t equal to 1, then it is I plus j. If t equal to 4, then it is 4I plus 16j. Direction has changed. I plus j means 45 degree from the x-axis. I 4I plus 16j, the angle will be different. But not only his magnitude is changing, its direction is also changing. Okay. Anyway, now the concept is same, that we have to divide the problem into n different parts. We have to divide the problem into n different parts and then solve part by part. This is the concept that we are started. We will see many hitch hatch here also. Okay, like if I'm trying to find circumference of a circle, we would have covered, I believe, infinite way to calculate the circumference of the circle. Infinite way. If someone is watching our all videos, then there would be infinite way of calculating the circumference of a circle. Hop, hop, hop. Okay, we are focusing now how to use a vector to calculate the nth part. Okay, now we are taking as we have already finished with delta x. Consider this is x-axis and this is the circumference of the circle. This is y-axis. This is x-axis. This is y-axis, and this is the circumference of the circle. This is the circumference of circle. How to find circumference of the circle? One way is chop this x-axis into n different parts. Chop the x-axis into n different parts. If I take any part, this is the first part, second part, ith part. This ith part move up and it will hit the circumference. This is the ith part circumference. This is the first part circumference, second part circumference. Okay, hope. This is the first part circumference, second part circumference, ith part circumference, nth part circumference. Okay, this is the half of the circumference of the circle. If I chop x-axis, now what is the half of the circumference of circle? Summation I equal to 1 to n perimeter of the ith section. So if this is the ith section here, it go up and match here. Then this is the ith section. Summation I equal to 1 to n and then parameter of the ith section. If I add all I, then I get half of the circumference. Okay, then we saw use of vector here. If I say the ith section here, if I say this ith section here, then there are 2 points here. One point is P1 one point is P2. They are coming, their main origin is the ith section on x axis. If this is x, then this is x plus delta x, where one section, if I divide into n part, then one section has a width of delta x. If this is ith section delta xi, all have same width. Delta x equal to 2a by n, where this is a, this is minus a, this is origin. This is origin, this is a, this is minus a. The width of each section, I have cut it into n different sections. Width of each section is 2a by n. Any width, ith section, if I go up, hit it here, then this is the parameter number ith section. If I add all the parameter, I get the complete parameter. Summation I equal to 1 to n, summation is sigma sign, sigma I equal to 1 to n, length of the ith section, length of the ith section. If someone computes in that fashion, length of the ith section, then summation I equal to 1 to n, parameter of the ith section. This is the ith section, this is the ith section. This point is, if this is x, then this is x plus delta x. If this is x, then this is x plus 2a by n whatsoever. Now these 2 points, one point is x1, y1, another point is x2, y2. Now if I say this is p vector, this is p vector, since this is origin connecting point x1, y1, this is p vector, this is p2 vector, p1 vector, p2 vector, x1, y1 and x2, y2, x1, y1, x2, y2. Okay, if that is the case, then there is delta p, p1, p2. If I connect these 2 points, then this is delta p. What is the length of delta p? Delta p is p1 minus p2 or p2 minus p1. Length of delta p is p2 minus p1, its magnitude. Makes sense? If I have a vector like this, I would repeat it. If I have a vector like this, consider this is p1 vector. P means position vector. Position vector is a separate kind of vector where one end is origin and another end is any point. If I have a point called x1, y1 and there is another point called x2, y2, what is the vector that is connecting x1, y1, x2, y2? x1, x2 minus x1i plus y2 minus y1j. This is called displacement vector. This is not position vector. Position vector means a vector with respect to the origin. If I connect a line from origin to x1, y1, that is called position vector. If I connect a point x2, y2 from origin 0, 0, that line is position vector. We call it P2. Consider this is P1 and this is P2. In that case P1 plus P2 will be another line that will go in this direction called P1 plus P2. P1 plus P2. Hope this line. Hope. I don't know. There is no stick out here. Okay. This is P1, this is P2, then this is P1 plus P2 in between it. Depends upon the strength of P1 and P2. But in abstract notation, this is P1 plus P2. Tell me what is P1 minus P2? This is P1, this is P2. What is P1 minus P2? Hope. I don't know what is P1 minus P2. What is P? This is P1, this is P2. This is P1 plus P2. Why this is P1 plus P2? That also I don't know. Okay, many times we have given this example. P1 is a vector and vector is not magnitude only, it has direction. So P1 is moving like this and P2 is moving like this. Just take prior to it. This is this is origin. If this is origin, then if I take it back, then P1 is coming from here. If I take P2 back, P2 is coming from here. They meet at the origin. If one force is coming like this and one force is coming like this, if they meet at origin, consider they become one single unit. It's like a mud is coming, a mud ball is coming in this direction, another mud ball is coming in this direction, and they stick together. Now one has force in this direction, one has force in this direction. So they will come and they stick together. And then, as per the force, if this force is more than this force, then it will go like this. If this force is more than this force, then it will go more vertical than horizontally. This force is more, then it will go more horizontal. What is this? This is P1 plus P2. Makes sense? If this is P1, this is P2, then this is P1 plus P2. But people they mug, they try to mug up. Okay, something like murmuring and okay, this is P1, this is P2. Why this is P1 plus P2? Okay, the way we said, if this is P1 plus P2, then tell me what is P1 minus P2? P1 minus P2. If that is true, so if it is P1 and P2, then P1 plus P2 will go in between it. What is P1 minus P2? Minus means opposite direction. P1 minus P2 is same as P1 plus and in bracket minus P2. What is minus P2? If this is P2 that is going in Y direction, this is X axis and this is Y. If this is P2 going in Y direction, then this is minus P2 going in minus Y direction, just opposite. That's it. Makes sense? If this is P2, then from origin just reverse it. This is minus P2. What do you mean? You mean that if this is P1, then this is minus P1. Yes, this is minus P1. P1 minus P2 means I move in this direction. Now tell me what is P1 minus P2? This, this vector is P1 minus P2. P1 plus plus means it will be between two vectors. Plus means P1 plus. Consider minus P2 is a third vector called P3. P1 plus P3. Tell me what it is. What is your P1? This is P1. What is your P3? This is P3. Then this is the P1 plus P3. Resultant in between it. So this is the vector addition and subtraction. Okay. Now, in similar fashion, we are saying that if this is x-axis and this is point I have taken for the IS section, this is P1 and this is P2. P1 and P2. These kind of explanation are not there in any of the book. Anyone can try. Read any book, any book. These explanations are missing badly. Okay, if this is the origin, this is point P1 and this is point P2, then this is P1 and this is P2. What is P1 plus P2? P1, P2 in between. This is P1 plus P2. What is P1 minus P2? This is P1, this is P2. Then this is minus P2. If this is P1 and this is minus P2, the resultant will go something like this. If I take it parallel, then it will come like this. A point connecting P1 and P2 points, then if I draw a line, then this will be another vector. That is P1 minus P2. Okay, if I calculate the magnitude of P1 minus P2, it will give the length of this vector. And length of this vector is the more or less the circumference of the IS section, provided this n tends to infinity. If I chop into n part, n tends to infinity, then the each part width is negligible, zero, more or less. If it goes up, then this IS section length, parameter length will behave like a straight line. Then if I calculate the magnitude of delta P, it will be more or less, it will be circumference only. Then what is circumference? Summation I equal to 1 to n parameter of the IS section, that is delta P of the IS section, its magnitude. Actually, story begins from here. Now, someone would say that can we I believe in previous video, if someone watched previous video, that is the summation and integral previous video, there we had given one assignment. In that assignment, we'll talk about the assignment. Now, someone would say, okay, thank you very much. Understood, understood. What you did is, this is x-axis, you chopped x-axis X-axis is considered as independent component and y-axis is considered as dependent component when we draw this curve y equal to square root of a square minus x square. X we keep changing and accordingly y also changes, means y is dependent upon x. Okay, can you do something more? Okay, we have something that is more. There x and y are dependent and r and theta are independent. There is another mathematics for polar coordinate system. If I draw polar coordinate system in xy coordinate system, in Cartesian coordinate system, then polar coordinate system is considered as independent component. They will keep changing r and theta. Accordingly, x and y will change. Now, x and y are dependent upon polar coordinate system, theta and r. What is the relationship? X equal to r cos theta, where r and theta are independent. X would change based upon r and theta. Y equal to r sin theta, where r and theta are independent and y is dependent upon it. Okay, now we can do in polar coordinate system. We have showed in the past video, past session. Okay, now in the past explanation. So if this is origin, then we have a radius like this, and radius is moving like this. So radius is not changing, but angle is changing. The angle it is making with the x-axis, angle is changing. Total angle is 2 pi. If I chopped x-axis into n part, x is minus a to a. Whereas if I chop this angle into angle, chopping the angle, this is the this is the angle that is moving like this, and this is 180 degree, 270 degree, and 360 degree. I chop this angle, 360-degree angle into n part. This is the first part. This is the second part. This is the third part. This is the ith part, any ith part. Then this is the n minus 1 part. I'm sorry, this is any other part. Then if I take like this is n minus 1 part, and this is nth part. Okay, like this. If I chop into theta, can you use your vector fundamental to calculate the circumference? You are talking about vector, right? Take any 2 point, calculate the delta p vector, calculate its magnitude, make n tends to infinity, and then you do your work. Okay, can we do in polar coordinate in vector technology? Yeah, we can do. Take any ith part. If this is consider this is ith part. This makes theta angle with the x-axis. This is delta theta I. Where radius, this is radius, this is the arc. Now tell me, okay, what is the length of circumference? If I'm calculating length of circumference in this fashion, this is the ith section circumference. This is the ith section circumference. Okay, that goes from here to here. This is x-axis and this is the ith part if I divide the angle, ith part. This is the ith section circumference. Now it has 2 points. One point is P1, one point is P2. If I subtract P1 to P2, this is position vector P1. If I take from the origin, this is position vector P2. If I subtract P1 to P2, I get delta P. If I calculate the magnitude of delta P, then it will give the length of the delta P. Now that is a more or less. If I divide this angle into n part, n tends to infinity. If n tends to infinity, then more or less delta P that we are calculating, this delta P that is a straight line, it will be more as same as the circumference. If this angle is 0, this angle is 0, then this straight line more or less. Now what is your formula? Same formula, summation I equal to 1 to n parameter of the ith section, that is delta pi magnitude where n tends to infinity. This will also give the circumference from the theta perspective. This proof is not there in any of the books. Someone can try. Okay, now what is delta P? This point is P1, this point is P2. This position vector is P1 position vector, this is P2 position vector. Delta P is a vector that is combining these two. If this is P2, then this is minus P2. Then delta P will be go in this direction. If I take it parallel, then it will exactly come like this. whereas P1 plus P2 will go in this direction. That is perpendicular to this. It will never come in this direction. But P1 minus P2, if I do exactly like this, then if you come in between, this line will be P1 minus P2. If I take it a parallel line, then it will exactly stick here as P1 minus P2. Makes sense? P1 minus P2. So this is P1 minus P2. If this angle tends to 0, then this line and this curve line will be of same length. I don't like this explanation, but this is how it is right now. Okay, in that fashion, what is P1 minus P2 delta P? This point is r comma theta r. We have demonstrated it. This point is r comma theta, someone would say. And this point is r comma theta plus delta theta in polar coordinate system. If this is delta theta I, then this is r comma theta, and this is r comma theta plus delta theta. This is theta with the x-axis. Now, what is this? If I talk in position vector, this is r unit vector. In pure polar coordinate is not mentioned in any of the book. Anyone who try. What is polar coordinate system? Then what is polar coordinate? X equal to r cos theta, y equal to r sin theta. Then r cos theta I plus r sin theta j. So this will be r cos theta I plus r sin theta j, and this will be r cos theta plus delta theta I plus r sin theta plus delta theta ij. I means I is section, not that I. This is I and this is j. Okay, then you have to, this is cumbersome. Anyone can try. I'm not saying that don't try, stop it here. Someone can try. Okay, in pure polar coordinate system, this point will be r comma theta. Theta is the angle, r is the displacement. So I have to take both as displacement. In that fashion, if this angle is theta, then this displacement in polar coordinates, I'm not talking about this displacement. This is y, that is r sin theta, and this is x, that is r cos theta. Polar coordinate system, this displacement is different. This displacement actually represents the theta displacement. As I move the radius, the theta angle is changing. Accordingly, this arc is changing. Radius is constant. What is changing? Theta is. Someone would say, no, 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 not only theta is changing. Arc is, see, there is no arc here. Then arc is building up. Means arc is guided by angle theta. If I am at any angle theta, this point is r comma r theta. This is r theta. Okay, in that fashion, now I have two position vector. One is r unit vector plus r theta theta unit vector. Another is r unit vector plus r theta plus delta theta I theta unit vector. Delta p will be now r delta theta I theta unit vector. If I subtract, r will go up, r theta will go up, r delta theta I theta unit vector, that will be delta p. Summation I equal to 1 to n. Summation I equal to 1 to n, where n tends to infinity, and then r delta theta I, that is the length of the ith section. If I say the length, the actual is summation sigma sign I equal to 1 to n tends to infinity, and then perimeter length of the ith section. The perimeter length becomes delta P1 minus P2, that becomes delta P of the ith section. Delta P of the ith section become R delta theta I. This is delta theta I. This is theta. R into delta theta I. R into delta theta I. Actually, it is, if it is theta, this is R. Indeed, it is R delta theta I only. R delta theta I, magnitude of R delta theta I, theta unit vector. Okay, what is r delta theta I theta unit vector magnitude? It will be r delta theta I only. That is r into delta theta I. It is as good as function over theta into delta theta I. Function over theta into delta theta I. Summation I equal to 1 to n tends to infinity. It is a fit case. This will be considered as the area of a substring. If I have a function over theta as a function, and this is theta angle, this is function over theta axis, then at any moment function over theta at the ith part, If this is the ith part, then what is theta of the ith part? At any moment, function over theta at the ith part. If I take theta axis and function over theta axis as a 90-degree axis, then at any moment theta at the ith part, if I take function over theta, that will be a vertical line into delta theta I. That will be a area strip, vertical line into delta theta I, area strip. This is the area sub area. If I add for all I, it gives the full area beneath a line that is function over theta. This is a this is a function over theta. Oh, how many times I, if this is a function over theta, if this is a function over theta, then at any theta, function over theta is the height into delta theta I. This is the area strip. If for I equal to 1 to n, if I add all the area strip, this gives function over theta d theta, that is the full area under this. Means this is a fit case to transform into integral calculus. Vector to summation. Summation to integral calculus. Now it is summation theta 0 to 2 pi function over theta d theta. Function over theta is r, which is constant. Now it is r d theta, r outside d theta, theta 0 to 2 pi. 2 pi r is the circumference of the circle. Okay, now someone would say, up, why you are running this much speed? I have another circle equation where radius is a function over theta. Radius is not constant. You took radius as a constant. Yes, we took radius as a constant. Radius is not constant. Radius is function over theta. What are you talking about? Radius is function over theta. Okay, can you tell me something? R equal to cos theta, R equal to sin theta, R equal to cos theta plus sin theta, R equal to, I think so, 1 plus b cos. There are many things where radius is function over theta and it makes a curve. R equal to cos theta, R equal to sin theta. Indeed, it makes a sine circle. R equal to cos theta. Consider this is origin. R equal to cos theta when angle is 0. Then R is 1, R equal to cos theta. This is 1. Then radius is moving. When angle is 45 degree, R is 1 by 2, radius reduced. Angle is 90 degree, radius is 0. It makes the semicircle. When angle is more than 90 degree, then radius will grow like this, but radius will be negative. So in this direction, radius will start moving. Opposite means negative. If this is negative, then opposite is positive. So angle is growing beyond 90 degree in this direction, but radius will start growing in this direction. It will form a full circle. Tell me circumference of that circle. R equal to cos theta as per your vector fundamental. Okay, now consider this is the circle. Then origin is here. This is not available in any of the book. Anyone can try. I'm not hiding it. Okay, anyone can try. This is x-axis, this is y-axis. Okay, this is origin, not this is origin now. And this is, and consider this is the radius. Radius is moving like this. Radius is at full plane here or along the x-axis. As radius is moving, radius is shrinking. Radius is shrinking and radius becomes 0. Then radius, instead of growing in this direction, radius starts growing in opposite direction for positivity. And then radius starts growing and radius becomes full. What is the angle? This angle is pi only. No, this is 2 pi. This is pi only, not 2 pi. Angle is pi. This is pi by 2. Yeah, this is pi by 2. Then this is pi. Yeah, this is pi. But this pi makes full circle. So angle is 0 to pi only. Actually, angle is moving up till here only. But this radius is negative. We made it opposite direction. And this is positive. This is negative. Beyond 90 degree. Then it unfortunately it made a full circle. So angle is from 0 to pi only. We moved radius from 0 to pi only, not full. Okay, angle is 0 to pi and radius. So radius is changing. What I'm trying to say is if this is x-axis, then if I cut this angle from 0 to pi into n different parts, then this is ith part. If this is ith part, then this is radius number 1 and this is radius number 2. This is delta theta I. Radius is also changing. If this is R1, then this is R2. R2 is smaller than R1 because radius is changing. In the ith section, if I talk, then radius is R1 minus R2 as delta R. Radius is changed and this angle is theta. then this angle is theta plus delta theta I. This angle, if I change the angle, radius is also changing. Now tell me, this ith section, what is the parameter? Parameter is same. Summation I equal to 1 to n. Parameter of the ith section, that is delta pi. If this is p vector, p1 vector, this is not there in any of the book. I challenge it. It's not there. If this is p1 vector, this is p2 vector. p2 minus p1 is the delta p vector. If n tends to infinity, then delta theta I tends to 0. Means more or less this will be more or less similar to the arc. The way we did, we will proceed in that way only. Let's proceed. Now we have summation of I equal to 1 to n, and then parameter of the ith section, delta p ith section, delta p magnitude ith section. What is delta p? P1 minus P2. What is P1? P1 is R1. This is R1. P1 is R1, comma R1 theta. This is the position vector. This is theta. So this arc will be R1, comma R1 theta. What about this position? This is R2. This is R2, comma R1, R1 theta plus delta theta. If I move like this, then this arc will be R1 theta plus delta theta I. What will be delta P? Delta P will be R1 minus R2. One position vector is R2 R unit vector plus R1 in bracket theta plus delta theta I theta unit vector. One is R1 R unit vector and another is R1 in bracket R1 theta unit vector. If I subtract, I get delta P. Delta P will be R1 minus R2 R unit vector plus R1 and in bracket minus with delta theta I. R1 minus R2 R unit vector plus R1 delta theta I theta unit vector. What will be? Let's denote R1 minus R2 as delta R. Makes sense? Indeed, it is delta R1. Delta R of the ith section. Delta Ri R unit vector plus R1 delta theta R1 delta theta I theta unit vector. This is delta P vector. What is its magnitude? Magnitude will be delta R whole square plus R1. Now let's say it R R square delta theta I whole square root. Okay, what is your computation of the circumference? Circumference is summation I equal to 1 to n and delta P ith section magnitude, that will be a square root of delta R of the ith section whole square plus R delta theta of the ith section whole square. R square delta theta, R delta theta of the ith section whole square root. Let's take out delta theta from here. Then it will become delta theta. I keep outside. Now square root of delta R by delta theta whole square plus R whole square. Delta theta I. Okay, if that is the case, no one has done it through the pure polar coordinate system. Okay, what do you mean? Now, this is a fit case. Now, there are two things. One is function over theta. Because R is function over theta, right? Delta R by delta theta, where delta theta tends to 0. This is a fit case to say dr by d theta. If R is function over theta, dr by d theta will be theta only, in theta only. Means the square root of dr by d theta whole square plus r square will be a function over theta only. Function over theta into delta theta I, the way we demonstrated earlier. It is a fit case to convert it to integral calculus. What are you saying? Okay, earlier you said that it is r delta theta, r d theta. R d theta brought the circumference of circle, I remember. But dr by d theta whole square plus r square root and then d delta theta. Means what will be your integral? Integral sign theta from 0 to pi. The theta is moving 0 to pi. Theta 0 to pi. Function over theta d theta. What is function over theta? A square root of dr by d theta whole square plus r square. What is r? R is cos theta. What is dr by d theta? Minus sin theta. I'm sorry, yeah, minus sine theta. Then dr by d theta whole square will be sine square theta plus r square cos square. Then sine square theta plus cos square theta is 1 only. Square root of 1 is 1. What is remaining? D theta only. What we will do with the d theta? We will do something with the d theta. Okay, what is d theta integral? Theta 0 to pi. Pi is the circumference, no, not cos. Pi is the circumference of the circle. What about r? R is variable. It vanished in theta. What is the circumference? Pi. Pi is the circumference. Let's calculate. Okay, if I'm talking about, consider now r equal to cos theta where angle is 0, then this is r and this is 1. Then it is moving like this, and then it is radius is moving like this up to pi degree, but radius is negative, we made it positive. Okay, it looks like this is a circle of radius 1 by 2. What is the circumference of circle which has a radius as 1 by 2? 2 pi r. R is 1 by 2. Hope pi 1. Pi is the radius of the circle. This approach is not available in any of the book. Okay, the way you are saying, can you prove it? What I have to prove? Try now in what we have learned is x equal to r cos theta and y equal to r sin theta. Through that way, can you prove it? We know x equal to r cos theta. We know y equal to r sin theta. Okay, now you have r equal to cos theta. R equal to cos theta, x equal to r cos theta, y equal to r sin theta. Can you prove the circumference of your circle is again pi with x and y? We will do. Someone can take it as an assignment where x equal to r cos theta and y equal to r sin theta and r equal to cos theta or r equal to sin theta or r equal to anything which forms a circle. And can you compute the circumference in this way? The way you are saying dr by d, I don't believe it is dr by d theta whole square plus r square. A square is a function over theta d is a sensational. Okay, that we will see. We will solve this and we will proceed. Okay, please don't mind supporting us. Please don't mind supporting us. Please mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.